we write in terms of log. If the function is log ax, x here must be positive, the value of x here. So base of this logarithm is base a. Base of logarithm is a, and the value of x there must be positive. That's definitions of logarithmic functions, for logarithmic functions. And we have looked at the base. And now base A, so the domain, when we see the domain of this function, which is logarithmic function, is when the value of x must be greater than 0. Or we can say that x in interval notation is from 0 until infinity. So whatever is here must be positive number, and this is represent base. Every logarithmic we have base. Since we see the connections between logarithmic function and exponential functions, for logarithmic function log ax, if and only if, let's say y equal to log ax, if and only if x equal to a to the power of y. See here, index here logarithmic. So the connections between them, between logarithmic and also exponential. Here exponential, here logarithmic. Connections between logarithmic and exponential function. So if not written base, we say that base 10. For example, if y equal to log x, without writing base here, understand that this is y equal to log 10x. If no base is written. If base is written, we have to follow what base. If not written, we say that base is 10. For log base is 10, you can see from your calculator. And if base E, we call that logarithms as what we call as natural logarithms, or you see ln. For example, y equal to log ex, we can write as y equal to ln x. This is ln 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 x. Any questions? Now we go for logarithmic functions.
Sir?
Yes?
Can we write log into LG?
Log itu?
Short form the log to LG.
Okay, can. But with base. Base is important. Without base also can, but without base, we say that base is 10. Now you can just write that. But base, if no base, we say that 10. We say that 10. So sometimes log E or log E, this is equal to ln. So later when you encounter with the word ln, so it's not peculiar for you because ln meaning that log with base E. Okay. So let's say log A1 equal to what? Can you relate the connections between logarithmic and exponents? So you get a value here. You get the answer here. Equal to what? Log A1 equal to what? You relate with the exponential functions.
Zero.
Zero. Why? When you relate, you get 1 equal to a to the power of 0, meaning that to get 1 here must be a to the power of 0 because everything to the power of 0 must be 1. Log A
1.
1. And also we have log a to the power of x. This is equal to x. You will see later when this is we use laws of logarithm, one of the law of logarithm, y is equal to x. And we have log a, index a. The index is in terms of log a x equal to x. This is index a. Index, but index in terms of log is equal to x. Questions? Then we have what we call law of logarithm. The first law, log log a with base a u times w, it's equal to log a u plus log a w. Log au plus log aw. Two log a u over w is equal to log a u minus log a w. When multiplied, when divide, minus. And number 3, log A u to the power of c, same as c log a u. So this apply for log with base 10, or we say common logarithms. This also apply for log with base e, or we call natural logarithms. Those 3 law of logarithms. Those 3 laws of logarithms. So, in a minute, see that if you remember, and the last number 3 that I asked you that before, maybe use this law, c multiplied by log au. C here we multiply by log au. Apart from those laws of logarithms, we also have what we call change of base formula. Change of base formula, log bu. We change to the base to 10, for example, log 10 bc base, change to base 10. Or maybe log bu change to base e. Say base. And remember that log e is ln. It's like the ln u divided by ln p. Ln u divided by ln b. Any questions?
No, sir.
Okay. Right. Unlike exponential functions, that we have the types of graph. Same for the functions. If for the case A is shape of the greater than 1, graph will be like this. The place crossing is 1, 0, and the function here is the functions of log ax. For case A located between 0 and 1, shape of the graph will be this. The function is the functions of log ax, provided that A located between 0 and 1, and the place of crossings x exists, same at point 1, 0. Only the way the shape different, the place of the cross and crossing now is crossing x axis. If you remember of the axis, but this case cross of x axis. Okay, when you look at the graph, with the graph on left, at this graph, um, what is the domain? What is the domain?
0 to infinity.
0 to infinity. Here, what is the domain?
Same, 0 to infinity.
0 to infinity. Range,
Infinity to infinity.
minus infinity, infinity. Here, range,
Same, infinity to infinity.
cross, x exists at point,
Y equals to 0.
no, point. We talk about point now.
1, 0.
1, 0. Cross x exists at point
One zero.
1, 0. And when we study exponential functions, we have asymptote. But here also we have asymptote, but location of asymptote is here. Location of asymptote is here. So our asymptotes now is no longer horizontal. It's become what kind of asymptotes?
Vertical.
Vertical. Vertical asymptote. Where? Where is the vertical? Where is the verticals of verticals asymptote?
X equal to 0.
When we talk x equal to 0, here also x equal to 0, here also x equal to 0.
Y exists.
Y exists. Or
Line x equal to 0.
line. Now remember this word, line. Line x equal to 0. So that we know that this line, where we talk about only x equal to 0, here also x equal to 0. Here x equal to 0 is not complete. To be complete, line y equal to 0. So when we talk about line y equal to everything. So similar here, we're going to have vertical asymptote. And where vertical asymptotes? Where is the locations of vertical asymptotes?
Line x equal 0.
Line x equal to 0, or maybe we can say as y exists. These characteristics of logarithmic functions, similar with the exponential functions, it depends on what? And remember that when we start beginning of study exponential functions, I told you exponential functions is one-to-one function. It does mean what?
Has inverse.
Exponential function has an inverse. And remember that day I said that we do not interested with the inverse. We're going to search or to find the inverse later on. Yes, we find the inverse now. The inverse of exponential function is logarithmic functions. Because exponential functions, if you remember the graph of exponential function for the case of a is greater than 1, like this. So remember when we study inverse function, inverse of the function will be reflection about the graph of the function by line y equal to x, this line. So when we reflect, we get graph of log. Or we can say the inverse of logarithmic function is an exponential function. Similar here. Remember that we have another kind of graph. So that's reflections about the line y equal to x there. So you can say that inverse of logarithmic function is an exponential function. Inverse of exponential function is logarithmic functions. question. Right. Any question, man? So then, like exponential functions, logarithmic functions also we can perform transformation. So transformations for exponential functions, same like transformation of transformation for logarithmic function, same like transformation of exponential function, and we can say same as transformation of function. Since those transformations apply for those whatever kind of functions, only a method that in chapter 2 we only focus for square functions, square root functions, cubic functions. But in fact, this is one of the functions, logarithmic function. Therefore, when we talk about logarithmic function, we also can apply transformation of that. Same like when we apply transformation for exponential function. We may have horizontal shift. And then we may have also, when we talk about horizontal shift, we will shift either to right or to left. What is the consequence when we shift to left or to right? What is the consequence for these logarithmic functions? When we shift to right or to left, what's the big consequence of that? What is the consequence of that? What's the big consequence? When transformations involve of the first transformations, horizontal shift involve of shifting to right or left? What is the big consequence when we talk about logarithmic functions?
Log ax plus minus c.
And consequence is asymptotes. Because remember that asymptote is here. When we shift to the left, asymptote will go left. We shift to the right, asymptote will go right. So the main consequence when shifting of the horizontal is asymptotes. For the exponential function, the main consequence when shifting the asymptote, where? Where? Which type of transformation? Which type of transformation mean of the shifting of asymptotes?
Vertical shift.
Vertical shift. In this case, horizontal shift. Because we can say that they are opposite to each other. And so we apply those 4 types of transformations. Apart from horizontal shift, what else? What else? The transformations.
Reflect.
Reflections. Reflection about what? We have 2 kinds of reflections.
Y-axis.
Y-axis and
X-axis.
X-axis. Apart from that, we say that the horizontal shift, reflections, and S, 2 more for the transformations, types of transformations.
Compress or stretch.
Compress stretch. And when we talk compress stretch, either compress stretch to what?
Vertical or
Vertical
horizontal.
or horizontal. And the last one?
Vertical shift.
Vertical shift. Vertical shift, either where?
Upward or
Up.
downward.
Up or down. Those are 4 types of transformations. And remember that transformations, not necessarily that all those 4 must involve in our question. Some of the questions, as we looked before, only involve of 3 transformations, or only maybe involve of 2 transformations. But if involve of 4 transformations, does not matter. We don't have 5 transformations or 6 transformations. How can? Because we only have 4 transformations. Any question? Right, if no questions, I stop here today. And inshallah, we'll see you back tomorrow at 11 o'clock. So I stop here with Tasbih Kifara and Surah Al-Asr.
Thank you, sir.
Thank you, sir.
Welcome.
Thank you, sir.
Welcome.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Welcome.
Thank you, sir.
Welcome.